So this paper is motivated by the rise in inequality, which we've been talking about also in the previous paper. It's motivated a lot of different policy proposals aimed at trying to narrow that gap between rich and poor, ranging from making taxes more progressive, wealth taxes, subsidizing college tuition for low-income households, and so forth. And so to evaluate these types of policies along with other ones, it's really useful to understand the dynamics first of income inequality. So one natural question for that is, are there forces that may narrow the gap between the rich and the poor? And so one such force, there are many others, but one such force is the potential rise in the supply of skilled workers, which through a canonical model would be a force that would lower the skill premium and potentially inequality. And what we're going to argue in this paper that such force is potentially weaker than we might have expected, because when people become more educated and become more skilled, they actually also change the composition of what they're consuming, and that compositional change is going to affect the firm supply of different types of skills. So specifically what we're going to be talking about is what we call trading up. So the idea is that when you have a rise in the level of income, people demand more high quality goods. And this high quality goods leads to a rise in the skill premium. The reason for that is we're going to show to produce these types of high quality goods or services, you actually need more skilled labor. And so as households increase the quality of consumption, this raises the demand for skilled labor and therefore contributes towards the rise in skill premium. Now that kind of quality upgrading can actually be quite big. So Greg talked a little bit about it already, but Beals and Clino, for example, estimate angle curves, and they estimate that each year it potentially would have risen by 3.8%, at least since 1980 where the sample begins. So what we're going to do in this paper is first to empirically show that it is the case people want more quality as they become wealthier, and that these high quality goods are more skill intensive. We then propose a model that's consistent with these two facts so that we can use it to understand the skill premium. Through the lens of the model, what we're going to see is that actually any type of shock that increases the level of the income is also going to increase the demand for skill. And then that endogenously leads to a rise in skill premium. So one implication of that is that we don't need as much skill-biased technical change as we might have thought to explain the 25% rise in skill premium that we've seen since 1970. So one thing that we do in this paper is to try to quantify and get a sense of, for the past rise in the skill premium, how much of it was due to skill-biased technical change versus other things. So what we do in this paper is feed in Fennell's estimates for TFP, and then feed in the quality change that's estimated by Beals and Clino, and then ask through this model how much skill-biased technical change do we need to justify that rise in skill premium. And this lens of the model suggests we need about 1% each year, which is orders of magnitudes less than what we see in the canonical model that doesn't have quality choice. That actually requires about 5 times as much. Okay, so we relate to very big literature on skill premium. What we're going to do is focus more on the structural change interpretations. How we're going to differ from the papers in the literature is the literature is focused on a cross-sector shift. So I spend less on food and relatively more on healthcare and services as I become richer. We're going to be looking more at within the sector. And one reason why it's actually important to think about within sector is because there are work that suggests a lot of the rise in income inequality is between firm within sector inequality. So we're going to be able to speak a bit more to those sorts of trends. Okay, so the first thing we do in this paper is we want to think of a way to measure quality, which is not directly observable. Now, there are different ways one can approach this. The first way is to proxy quality by relative prices of items within a category. Alternative ways would be to take a more structural estimation with utility functions combined with transaction on prices and quantity and back out what quality would be. You could also combine in the third approach information on costs of materials. 2 and 3 generally require stronger assumptions and more information. And so typically those papers focus on more narrow subset of sectors. We're going to go with the first one, And we think it makes sense for two reasons. First of all, there's actually strong evidence it's pretty correlated with 2 and 3. And what it's going to buy us is we're going to actually be able to speak to many sectors, services, durables, and non-durables, to show this is a trend across all of them. So the first thing we do is to show that as you become wealthier, you do consume higher quality goods. This is well known. It's well established in the literature, which have estimated quality angle curves. We're going to just show you a little bit with corroborating evidence based on our relative price measure. You also see that's the case. So you'll use the Nielsen home scan data on groceries. We looked at CEX for durables. And then we also looked at Yelp data, which covers a lot of different services. I'm just going to show you the CEX data and then just tell you it looks, you get similar sorts of trends that you see in the other sectors as well. Okay, so for the CEX data, what we did was we looked at the logo price this household pays for this type of good at time t, regressed on indicator variables for the income quintile, plus a range of different demographic controls. That's being plotted here on the table. So what we see is that as people increase in their income, they're buying types of goods that are more expensive, higher in quality. On average, the top income quintile buys goods that are about 80% more expensive than what the bottom quintile is spending. Now, this is quite large, but it's also not surprising because for durable goods, and we're talking about things like sofas, mattresses, refrigerators, most of the increased income there goes towards quality rather than buying more quantity. So I think this makes a lot of sense. Now, I've just showed you durables, but in the paper, we also show it for services and non-durables. The second thing we show is that, well, the types of firms that produce these high quality goods actually employ more skilled labor. So this is more new. So how we actually show this is we merge onto the microdata for occupation employment statistics from the BLS. We merge on the Nielsen information as well as the Yelp information for relative prices. And then we use the information here that has occupations, wages, and workers. For each of the workers, we classify them as high skill if their wage is above the average wage of college graduates in that industry. The paper, we consider a range of other classifications. I think this makes sense. So types of industries that have a lot of high-skilled workers include the finance, management, consulting industry, and ones that don't have as much include hoteling and accommodation. Just to give you one more example so that it's a little bit clear in your mind what types of skills and occupations we're thinking about through this data set. Here's the restaurant industry. So what we're going to see is we're going to look at within a sector and varying the type of quality of the firm. Do they employ more high-skilled labor? So for the restaurant industry, if we look at the types of occupations that this data set actually has, these are the ones that make up most of employment. Managers, executives, chefs, first-line food prep workers, waitresses, marketing, and sales. What's in blue is what's generally classified as high skill. And so what we can see is that, for example, if we vary by quality, and just take one of them, chefs, which are generally classified as high-skilled, requires training. If we go from limited service restaurants such as McDonald's, they only account for about 2% of all workers. We go to full service restaurants, it's about 20% of all workers. And if you go to a very nice restaurant called Alinea in Chicago, it makes up almost 1/3 of all of their workers. So we see here that they're actually employing more high-skilled workers. Now, what's interesting is it's not all just in marketing and sales. What we actually see is that as you increase the quality of what's being produced, there's more layers and hierarchy of different types of high-skilled workers. So you think there's something involved here where you transform the product to a high-quality good. So what does the data look like? So this is just grouping it by the different quality measures, low, middle, and high. The one on the left is based on Yelp, so mostly services. The one on the right is based on merging on Nielsen. So this is going to look at food manufacturing. So what you see here is that as you increase quality, you increase the share of high-skilled workers. It's about 1.5 to 2.6 times higher. And this is true both in employment as well as wages. So what have you seen? First of all, as people get richer, they consume higher quality goods. And second, to produce these higher quality goods, those firms employ more high-skilled workers. So what we then do is construct a model that has both of these features and think about what does it mean for the skill premium. Okay, so we're going to take a model that is as close as possible to the canonical model and then add two features, endogenous quality choice and that higher quality goods require more high-skilled workers. There are two types of workers, high and low skill. We're going to have them in, like the canonical setup, as exogenous labour supply, feeding in what is actually in the data. We consider two models. One is a homogeneous household model, and one is a heterogeneous household model that consumes different qualities. I'll just take us through the first one. But the economic intuition I'm going to describe to you basically carry through to multiple goods. Okay, so this is a homogeneous household model where the household pulls all of the resources from low and high skill workers. They're going to consume one unit and choose the quality. Now, we set it up this way just to simplify it so I can show exactly analytically where things differ compared to the canonical model. But at the end, I'll talk about what happens if you add in quantity as well. Okay, on the production side, we have a very similar setup in that you have high-skill workers, low-skill workers. Rho governs the elasticity of substitution between the two. A is TFP Hicks neutral. S is a skill-biased technical change. What we're adding is Q. When Q enters in this way, for the calibrated parameters we end up having, it's going to have two features matching the data. The first is that price is going to increase with quality, which is basically what we assumed in the data. This is the equilibrium price. The second part is that quality is going to be more intensive in skilled labour. And we can see that from the firm's first order conditions down there. We take the log of the firm's first order conditions, we get this expression. Now this expression is what the papers in the canonical literature take to the data to estimate how much skill-biased technical change do you need in order to rationalize the rise in skill premium on the left-hand side, given the change in labour supply we see in the data. So you back out the change in S you need. Now notice here we have an extra term, which is from quality. So from here you can already see, because we have another factor driving skill premium, we don't need as much skill-biased technical change as we need it in the canonical model. In fact, quality is going to play three roles economically in this model. This is the equilibrium quality that's demanded, and quality is going to do two things. First of all, it's going to amplify any changes in the skill-biased technical change. And we can see it here. It doesn't work. We can see it here in the sense that if the skill-biased technical change increases on the top equation, that's going to lead firms to want more high-skilled workers because now they're more productive, and that's going to push up the skill premium. But notice if the skill premium goes up, the average income for the household, the level is actually going to be higher as well. And because they have higher income, they're going to demand more quality. Quality is going to enter that first equation, and that's going to lead firms to want even more high-skilled workers. So it's going to amplify that effect. The second thing it's actually also going to do is that any increase, not just a skill-biased technical change, can also lead to skill premium going up. So for example, a Hicks neutral change, which doesn't have a role in the canonical model, here it will, because when you have a rise in Hicks neutral, that's going to lead average income to be higher. People are going to demand more high quality goods. That's going to further push up the skill premium. The third thing, which is kind of interesting about labour supply, the existence of quality is actually going to dampen, for given parameters that we have, dampen the effect of a rise in labour supply. So what happens here in the usual model is if you have more supply of high-skilled workers, that's going to push down the skill premium. But the net effect on average income is actually going to go up because you have more of these high-skilled guys. So even though the skill premium goes down, the average wage is higher. Average wage being higher means that the household would want more quality, and that's going to offset some of the labour supply effect. Okay, so that's what's happening economically in the model. We then take a first pass at trying to get a sense of how important are the different factors. Now, I'm going to show you our baseline results and at the end talk a bit about how you might want to extend this. We're going to ask, given the rise in skill premium from 1970 to 2008, it's about 25% increase, despite the fact that labour supply of skilled workers has gone up, how much skill premium, skill-biased technical change do you need? So what we do is we feed into the data labour supplies, the skill premium, TFP from Fernald. We have calibrated parameters, elasticity from Acemoglu and Autor, and then we feed in the Beers-Inclino rise in quality to discipline the gamma. We then use it to infer how much skill-biased technical change do you need to justify the rise in skill premium. Okay, so here are the results. First of all, if you had no TFP or skill-biased technical change, but an increase in labour supply of skilled workers, then of course the skill premium itself is going to go down. It goes down by a lot in the canonical model, and it goes down by much more in the canonical model than what we have in our trading down model, because of the fact that when there are more high-skilled workers, there's an endogenous response from quality that offsets some of that decline. Now, we can then say how much skill-biased technical change do we need to justify that rise in skill premium. In the canonical model, this is what they do. So there's a 25% increase in skill premium. And through the lens of this model, you actually need 5.5% increase in skill-biased technical change every year to get the skill premium going up. The TFP actually plays no role here. But notice it's orders of magnitudes bigger than the per period TFP increase. Now we can ask the same question in our trading up model. And notice here we now only need about 1% increase in the skill-biased technical change. And the reason is because quality is actually amplifying a lot of the income increases in this model. So then we can also ask, how important are the other shocks? So the other shocks that can be playing a role is TFP, the Hicks neutral. So we can also ask, how important is Hicks neutral for driving up the skill premium? And we see that it accounts for about 1/3 of the increase. So what are the key takeaways? First of all, smaller changes in the skill-biased technical change can lead to pretty big increases in the skill premium. Secondly, and this is important going forward, even if there's no more skill-biased technical change, the fact that average income is going up can potentially lead to an increase in skill premium and inequality in the future. Okay, so the very last thing I'm going to do, which is a more heroic exercise, is to say what might happen going forward. So one thing that we can do is just say if it was the case that the college graduates continue to linearly increase, and this doesn't do any of the cohort adjustments or compositional adjustments and selection we talked about. All it does is say, what if we just had taken the trend from 1990 going and it continuing to increase to 2026, combined with Fernald's forecast of TFP? What would happen to the skill premium? What we see is that if there's no TFP shock, then because you have more skilled workers in the canonical model, that's a force that will narrow the skill premium and inequality when you have more college graduates. In our model of trading down, because there's a quality response, having more high-skilled workers doesn't reduce it quite as much. It's a bit less there. And in fact, once you add in TFP, we actually have the skill premium continue to rise. All right, one last thing on robustness, and then I'll conclude. So we've set it up to look like the canonical model, but if you extend this to have a heterogeneous household with different qualities, or if we allow for quantity choice here, what we've done is to say now you actually choose between a homogeneous good and a good where you can vary quality. We take the Beers-Inclino setup exactly, and then redo our exercise. And you get things that are actually not that different from what we have, because a lot of the upgrading comes through quality. Okay, so let me conclude. What we've seen is quantitatively, we seem to need less skill-biased technical change to rationalize the observed rise in skill premium. Actually, any shock that boosts income can potentially increase the skill premium. Some policy implications, if we take this literally, is that policies aimed at increasing the supply of high-skilled workers through the lens of the canonical model, we know that's going to reduce the skill premium and inequality. What our paper is saying is that you actually need these types of policies are potentially less effective than we would have otherwise have thought. And the reason is because when they become more skilled, they actually change the composition of consumption and the demand for those different types of workers.